Hello. Let's take a looky-loo at some properties of covalent molecules. You're going to be doing a lab in class, which is going to get you a little bit further in your understanding of properties of covalent molecules, but we're going to go ahead and take a look right now as well. We want to take a look at the difference between nonpolar molecules and polar molecules in terms of things that they do. And when we start to understand intermolecular forces, this is going to make even more sense. But for right now, we're just going to go with this. Okay. In a nonpolar molecule, remember, if you have a nonpolar molecule, you've got a central atom, you've got four things that are exactly the same around, or three things, or two things, whatever, five things even. As long as every atom is the exact same around a central atom, it's considered to be nonpolar. So like AsBr5, you have bromine, 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 or NH4 plus. You'd have hydrogen, 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 hydrogen. Okay. So those are going to be examples of nonpolar molecules. Anything that's nonpolar is going to have a low melting point and a low boiling point. Okay. Most of these are not going to be solids. They're going to be either liquids or gases at room temperature. They're not going to conduct electricity. They're going to be insoluble in water for a reason which we're going to figure out at a later time. And these are going to exist as molecules. In other words, they're not ionic compounds. Okay. Anything that's covalent is going to be considered to be a molecule. So that's nonpolar. Polar molecules have slightly higher melting points and boiling points um, than their nonpolar counterparts. And if we remember, a polar molecule is where you have your central atom and everything around the central atom is not the exact same. Okay, so for instance, if you had like methyl fluoride, you had your carbon in the middle and you had hydrogen, 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 fluorine. That's not the same thing all the way around, so therefore that's going to be polar. Also, anytime you have an unshared pair of electrons, like if you have ammonia and you have nitrogen in the middle, you have hydrogen, 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 unshared pair. Okay, that unshared pair is not the same thing as hydrogen, so therefore that makes it polar. Okay, like I said a moment ago, these have higher melting points and boiling points than their nonpolar counterparts. Most of these also are going to be liquids at room temperature. These do not conduct electricity in any state. They're typically going to be soluble in water. And these are also going to exist as a molecule. Now, we also need to understand the idea of what the polarity of a bond is versus the polarity of a molecule. If we are referring to a bond, let's take a look at this carbon to chlorine bond. We see that there is a difference of 3.0 to 2.5 in terms of the electronegativity. Since that difference is greater than 0.2, we would say that this is a polar bond. Okay. Now, when we look at the molecule as a whole, we've got chlorine, 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 chlorine around the central atom. So since we have all four things that are the exact same, this would be an example of a nonpolar molecule. Okay, now in this other one over here, we switch out a hydrogen for the chlorine. So now we've got four polar bonds. Okay, here's a polar bond, here's a polar bond, here's a polar bond, and here's a polar bond. But now, in terms of our molecule, not just bonds, but molecules, in terms of my molecule, I've got chlorine, 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 and hydrogen. So I've got things that are different around the central atom. So that's going to make this a polar molecule. Okay, now it says the reason why you saw the trends of solubility is that like dissolves like. Okay, meaning that polar substances dissolve in polar solvents. Okay, water is polar, so water is going to dissolve polar covalent solutes. Okay, and a non-polar substance will dissolve in non-polar solvents like oil. Okay, so if I were to ask you on a test or a quiz if something is going to dissolve into something else, then you would tell me yes or no based on like dissolves like. Okay, polar things dissolve in polar things. Non-polar things dissolve in non-polar things. However, polar covalent compounds will never dissolve in a nonpolar covalent solvent. So let's take a look at CF4 right here. With CF4, it wants to know how many polar bonds are there. Is the molecule itself polar? Is it going to be more likely to dissolve in water or oil? So the way that we would figure that out is we have to draw our Lewis dot structure. So let's take a look at CF4. I know that carbon brings 4 valence electrons to the table. Fluorine brings 7, and I've got 4 of them, so that's going to bring 28 total, meaning that I've got a total of 32 electrons. So I know carbon's in the middle with 4 fluorines around it. And now I've used up 8 electrons. I've got 24 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So I've used all 24 of my electrons, so we're feeling pretty good. Now the question is this going to, or let's see here, how many polar bonds are there? Well, I've got fluorine to carbon, that's a polar bond, fluorine to carbon, polar bond, fluorine to carbon, polar bond, fluorine to carbon, polar bond. So there are 4 polar bonds in this molecule. Is the molecule itself polar? Well, I'm going to look around my central atom. I'm going to see, is everything the exact same, or is there anything different? Fluorine, 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 fluorine. It's all the exact same, so the molecule itself is nonpolar. Oops, nonpolar. There it is. Okay. Now, the question is, would it be more likely to dissolve in water or oil? Well, I know that water's polar and oil is nonpolar. So since this is a nonpolar solute, it's going to dissolve into a nonpolar solvent. So it's going to dissolve in oil. Okay, let's take a look at this next one as well. Ammonia. Okay, if I'm going to draw my Lewis dot structure for ammonia, I know NH3. Okay, I know that nitrogen brings 5, and each of these hydrogens bring 3. So I've got 8 total electrons I'm playing with. So I'm going to put my hydrogens around. I've got to satisfy my central. 1, 2, 3, 4, 5, 6, 7, 8. And that's it right there. Okay. So now I want to know how many polar bonds are there. Well, I've got nitrogen to hydrogen. So there's a polar bond, polar bond, polar bond. So there's 3 polar bonds. Is the molecule itself polar? I've got hydrogen, 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 unshared pair. Since it's not all the same all the way around, I know that it is indeed polar. Okay. Would it be more likely to dissolve in water or oil? It's going to dissolve in water since it's polar. Now let's take a very quick look at metallic bonds as well. There's not a lot that I need you to know about metallic bonds. So I'm just going to go over this real quickly on this same video. Okay. The only thing you need to understand about metallic bonds is the fact that you've got a sea of electrons, and that's what's going to bond your metals together. Okay, so you've got all your little metal atoms, and then there's a sea of electrons which swims around in between those atoms. These are going to have extremely high melting points and boiling points because these are very strong bonds. Okay, they will conduct electricity in their solid or their liquid state. Okay, since you've got free electrons moving around, that's going to cause it to be able to conduct electricity. These are going to have a luster, meaning that they're shiny. They're malleable, meaning that they can be bended or hammered, and they're also ductile, meaning that they can be drawn into a wire. If you mix metals together, then that is going to give you a metal mixture called an alloy. Okay, that's just a definition word. That's just a vocab term that you need to be aware of. Okay. So we will take a look at we've got one more video after this over intermolecular forces, and then that will be the end of Unit 6. So there we go.